As the semiconductor industry moves towards ever-increasing miniaturization, the requirements for the purity of bulk chemicals are dramatic. A phenomena that limits purity and safety in bulk chemical delivery is the water hammer effect. A water hammer occurs when a valve suddenly closes at the end of a pipeline system, and a pressurized wave propagates in the pipe. In conventional chemical delivery systems with pressurized vessels, water hammer can reach alarming peaks, which can cause particle generation or even pipe collapse. A look in super slow motion shows how the wave-like form of the water hammer is generated. The water hammer also has an impact on the filter. A transparent filter housing visualizes the effect on the filter membrane during a water hammer. Due to the hydraulic shock, the filter membranes swell up and move, allowing small particles to be pushed through the membrane. To summarize, a sudden closing of a valve causes a hydraulic shock known as water hammer. Pressure peaks of the water hammer are so high that they can cause major issues, and filter performance is reduced due to water hammer. Compared to a pressurized vessel system, a normal, non-pressurized tank in combination with a pump is used. A recirculation loop minimizes the water hammer effect and additionally purifies the liquid. With this setup, a sudden closing of the valve causes virtually no water hammer, as the liquid column is directed into the recirculation loop instead of hitting the valve. Smaller water hammer also implies a smaller effect on the filter performance, since there is no backflow. Visualization of the filter membranes shows no motion. The overall filter movement is drastically smaller than before, leading to a fuller filter performance. Overall, it can be said that chemical delivery with a Levitronics pump system drastically reduces the water hammer effect, ensuring safe and pure processing of ultra-pure chemical onto the wafer. Levitronics, better pumps for better yield.